So let's do an example of the multiplication rule. And while the textbook offers formulas on how to work this through, I'm going to actually be using critical thinking and logic, because at work you might not always remember these formulas. And so let's apply a logic approach. So let's say we've got a batch of 50 cell phones and it contains 4 phones with a defective or bad battery. So if the phones are randomly sampled from the batch and inspected one at a time, we will be calculating a couple of different scenarios. So let's say in our first situation, we want to know the probability that the first cell phone is defective. So what we want to do is think about or imagine I've got a batch of my batteries right in front of me. So that'll be the 50 batteries. And then I'm interested in the defective ones, and I know that there are 4 of them. So I'll go ahead and put my 4 at the top of my fraction here. And then using a calculator, I'll go ahead and divide 4 over 50. And you can type this in Excel too, if you're comfortable with Excel, equals 4 divided by 50. And we'll end up with a probability of 0.08. In other words, this is an 8% chance of happening. Let's go ahead and do another scenario. Let's see, say we're interested in the probability that the first cell phone is good and the second cell phone is bad or defective. So I'll just write defective. Okay. So again, it's helpful to imagine I've got my 50 phones in front of me. And so if I look at the one good, what are the odds? And so I've got my batch of 50 here, but how many are good? So of my 50 phones, I know 4 of them are bad. So to find out how many are good, I'll go ahead and take 50 minus 4. And so I know that I have 46 good batteries. So I'll go ahead and throw the 46 on top. Now we are doing the multiplication rule, so I'll put an X here to remind myself to multiply. But now I need to figure out, okay, what's the odds that my second phone that I pull out of the batch will be defective? So I'll go ahead and draw my line. Now, since I've already taken out one phone, that means I've changed my batch. I now only have 49 left in the pile. And I'm interested in defective, and I know I've got 4 of them in there, so I'll go ahead and put the 4 on top. And then what I can do is, with a calculator or with Excel, you can solve each fraction separately and then multiply them, or you can multiply across 46 times 4 and 50 times 49, and then divide the 2, and what we'll end up getting is 0.0751, or 7.5% chance that our first phone is good and our second phone is defective. All right, so I've cleared the board, and let's say in our last scenario, we're interested in the probability that the first 3 sampled cell phones are good. So you can see here I've written our first phone I pull is going to be good, our second phone is going to be good, and our third phone is going to be good. So we'll want to use the multiplication rule with this. So I always imagine I've got my pile of phones in front of me, all 50 waiting to get pulled. And since I'm interested in the good, and I know how many bad, so 50 minus 4 again, that left us with 46 good phones within my pile. And then for our second draw, right, so imagine I've already taken out one phone, put it over on the side, and that'll leave me with how many in the pile, right? I've taken one out, that means I've got 49 left in the pile. And again, I'm still interested in good, but I've already taken out one good phone, so how many good phones are left? That's going to be 45. And then now I've got that second phone that's good, accounted for. I'll pick it up, set it aside. Now I'm interested in the third draw, or my third phone. So again, I've got my pile. I've already taken 2 out. How many are left waiting to get pulled? That's going to be 48 in the bottom. And again, I'm still interested in good. So how many good phones do I have left in the batch? Well, I already found 2 out of the 46 available. So I know I've got 44 good ones waiting in the pile and hoping that I pull it, right? So these are the probabilities for our first, second, and third pulled phones. All of them are good. And we'll go ahead and use a calculator or Excel and find the fractions, multiply them, or multiply across, and then divide. But we'll end up with a probability of 0.7745, or 77.45% chance that the first 3 phones are good. So hopefully that helps you see how probability can be approached from a critical thinking standpoint. And if you've got questions, just let me know.